Hello there, Chargers. It's Mrs. Boyd coming at you with section 4.1, Algebra 2A, graphing quadratic functions. Let's get right into it. It's really exciting. It's one of my favorite things to talk about. Take that with whatever excitement you might. The graph of a quadratic function is called a parabola. Not a parabola, parabola. That's what it's called. And it looks like f of x equals ax squared plus bx plus c. That's the standard form of a quadratic equation. A is the quadratic term, which means it's right in front of the x squared. B is the linear, it's in front of the x, and c is the constant. It has no, it's a number with no letter. A couple things we want to know about these equations. The y-intercept is c. That's when x is 0. That's the only thing that's left when x is 0 is c. This is the case in every quadratic equation. The axis of symmetry, which I'll be abbreviating as AOS because I hate writing all the words, is x equals negative b over 2a. It is an equation for a line that we care about. So x equals negative b over 2a. The vertex is that x value, x equals negative b over 2a. And the y value, when we replug that number back into our equation. Let's put this into action. Example 1, find the y-intercept, blah, 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 all these things of this equation right here. Let's write down what we know. A is this imaginary 1 that's laying right in front of x squared. So A is 1, B is 6, C is 8. So we'll use what we know to find the y-intercept, the axis of symmetry, and the vertex, and then we'll graph it down here. The y-intercept is c, and c in this case is 8. So if we come down to our graph and we go to 1, 2, 3, 4, 5, 6, 7, oh, it's above the graph. We're going to put a little dot right there. That's our y-intercept. Axis of symmetry, x equals, I'm going to give you a hint here. Always put the negative and the negative b over 2a on the top with the b, so you don't forget it. So always write x equals negative, I don't care if your b is negative or not, you're going to put b in parentheses, negative 6 over 2 times a. Duh, Amanda. So 2 times 1. So that is negative 6 over 2, otherwise known as negative 3. So when we draw the axis of symmetry, we're going to draw a dashed line, 1, 2, 3. It's always going to be a vertical line on that equation. So it goes right there. So we've got a y-intercept, we've got the axis of symmetry. Now we need to know the vertex. So we can plug in negative 3 into our equation and see what we get for f of x, for the y. So and negative 3 squared plus 6 times negative 3 plus 8. That is 9 minus 18 plus 8. Now we work from left to right. 9 minus 18 is negative 9 plus 8. So that's negative 1. So the vertex is a coordinate point, and it's going to be at what did we just say? Negative 3, negative 1. So we go down 1 on the axis of symmetry, and that's the vertex. So here's the fantastic thing about parabolas. They're symmetrical around this axis of symmetry, hence the name. So we know our handy-dandy y-intercept is on the y-axis. We also see that there are 1, 2 empty lines between the axis of symmetry and that point. So I know that 1, 2 empty lines on the opposite side, they'll be the exact same point. So right here will be the same point. See, symmetrical on either side of the axis of symmetry. Let's plug in a few more points just to see what we get. Let's plug in x is negative 1. So we get negative 1 squared plus 6 times negative 1 plus 8. That's 1 minus 6 plus 8. From left to right, negative 5 plus 8 is 3. So when x is -1, y is 3. So let's plot that. Now, we know with one empty line on the other side, we'll have the same point. Last one, let's plug in -2 for x, plus 6 times -2, plus 8, that's 4, minus 12, plus 8. 4 minus 12 is -8, plus 8 is 0. So when x is -2, y is 0. That also means when x is -4, y is 0. Now we can draw a parabola. We did it. Hooray, it's a parabola. Let's do another one just to make sure everybody's got the gist of the idea here. We've got same idea, new function, -x squared minus 2x plus 2. All right, looks like our a is -1 this time. B is -2. C is 2. Y-intercept all the time is C, which is +2. So let's plot that point on our graph already. The AOS, or the axis of symmetry, x equals -b over 2a. For our case, that is x equals -2 over 2 times -1. Well, negative times negative on the top is +2, and 2 times -1 is -2. So that means the axis of symmetry is -1. So we can draw in our little dashed line there. Vertex, we're going to plug in -1 to our parabola equation here and see what we get. So -1 squared minus, 2 times -1 plus 2. Well, -1 squared is 1, so that's -1. -2 times -1 is +2, and then that's plus 2 on the end. 2 minus 1 is 1, plus 2 is 3. So that coordinate point is -1, 3, where the vortex is. Did I say vortex? Totally a vertex. Ignore that. All right, so I know there's a point at -1, 3. I know that 1 to the right of the axis of symmetry, x is 2, or y is 2. So that means that 1 to the left, y is also 2. Let's plug in one more point just to be safe. Let's plug in 0. Oh, that's 2. Let's plug in x is 1. So we have -1 squared minus 2 times 1 plus 2. Well, that's -1 minus 2 plus 2 is -1. So when x is 1, y is -1. And that's 2 to the right of the axis of symmetry, so 2 to the left. It's also -1. We have all the things we need to draw our pretty little parabola right there. There we go. Moving on down. All right, next we're talking about the graphs and what they mean. Oh Lord, it's late. All right, so we have a graph of a parabola here. And we want to look at when a is greater than 0. That means our parabola opens up, like the first example, where it looks something like that, and has a minimum value. That means there's a point down here at the bottom of our cup that nothing will ever go below. When a is less than 0, so a, we're talking about this a right here, our parabola opens down, something like this, and has a maximum value here at the top of this umbrella where nothing can ever go above it. So we first can find if our parabola has a maximum or a minimum, and then we can look at what the domain and range are, which is what we'll be talking about very next. So we want to know if there's a maximum or a minimum, and then give the domain and range from that. So let's look at what we've got. We need A and B to figure out if we have a maximum or a minimum. A in this case is 3, B is -6. To find out, first we have a maximum or minimum, we look at A. A in this case is 3, that's greater than 0. That means it's going to look like this. So it's going to have a minimum. A is greater than 0, it opens up. A is positive, your parabola opens in the positive direction, and there's a minimum. So the vertex, we need it first, we need the axis of symmetry. That's x equals negative b, negative 6, over 2 times a. Well, that is positive 6 over positive 6, and that's 1. So a vertex, when we plug that in, we get 3 times 1 squared minus 6 times 1 plus 7. That's 3 minus 6 plus 7, or negative 3 plus 7, or 4. So the vertex is 1, 4. So now you're saying to yourself, how do I find the domain and range? Well, the domain is always all real numbers, all the time for all parabolas. The range is going to be x, or I'm so sorry, it's y. Forgive me. And that's the y portion of our vertex. In the middle, if it's a minimum, it's going to be less than, greater than or equal to. Holy cow, I'm doing all the mistakes today. So if we look at my little baby graph up here, if this is 4, if y is 4 here, then all the other values of y are greater than 4. So that means our range is y is greater than or equal to 4. Let's look at another one. We've got 100 minus 2x minus x squared. First, let's rearrange this and make it look normal. F of x equals negative x squared minus 2x plus 100. A here, now that we've rearranged, is negative 1. B is negative 2. Maximum or minimum. A is negative. That means it's going to open down. If A is negative, your parabola opens to the negative side. So that's going to have this point at the very top. That's a maximum. So the vertex, first we need the axis of symmetry. That's x equals negative b over 2a. In our case, negative 2 over 2 times negative 1, or 2 over negative 1, or negative 2. Then for the vertex, we plug it back into our equation. So negative 2 squared minus 2 times negative 2 plus 100. So that's negative 4 plus 100. That's just 100. So the vertex is negative 2, 100. Again, the range cares about that number. Domains, all real numbers, all the time. Range, y, the y portion of our vertex. It's a maximum, so all the other y's are below it. So y is less than or equal to 100. I think that's all we've got. Yep, looks like it. So I hope this makes lots of sense and you can move on and be uber successful and know exactly what you're doing. Good luck. Let me know if you need any help.